In this video we're going to be looking at the sampling distribution of a statistic. The sampling distribution of a statistic gives all the values of a statistic and the probability that each would happen by chance alone. Now what this is where you take a sample of something and you look at the different statistics that could happen. So if I took a sample of some trees in a forest and I measured the heights of those trees, if I took another sample, they could have a completely different mean, they could have a completely different median value. So we could see that samples of the same population can produce different statistics. And we're going to be looking at the probability of each different type of statistic coming out. Let's look at this in the context of a question. A bag contains a large number of counters. A third of the counters have a number 5 on them, and the remainder have a number 1. A random sample of 3 counters is selected. A. List the possible samples, and B. Find the sampling distribution of 1. The range, 2. The mean, and 3. The mode. Okay, so these questions are generally split up into these two parts. The first part is always, well, almost always, to list the samples, all the possible samples that you could get. And then the second is to find the probabilities of each of these different statistics. So if I did a sample, each of the samples could have a different range, and we're finding the probability of each range coming out, each mean, and each possible mode. So looking at the first part, we have two options, either counters with a number 5 on them or counters with a number 1, and we have to make 3 choices, or 3 counters are selected. So we have to be very methodical when we're doing these types of questions. So for part A, the way I like to do it is start numerically. So I start with, we could have a sample with 3 1s. We could have a sample with 2 1s and a 5. And that could come up in a variety of combinations. So it could be 1 1 5, could be where the 5 is the second one drawn, or it could be where 5 is the first one drawn. Now, want to look at where there's 2 5s and 1 1, so that could be 5 5 1, 5 1 5, and 1 5 5. And then finally, the other possibilities where there are 3 5s drawn. Now here we've got 8 different combinations, and the way that we could check that we've got all of them is you look at the number of options, which is 2, and you put it to the power of the number of choices, which is 3, and that gives you the total amount of combinations, and that is indeed 8. So we have the total number. So this is a very handy thing for you to try and remember. You can always find out the total number of choices or combinations that you should have by putting the number of options to the power of the number of choices. So now let's move on to the second part. We need to find the sampling distribution of the range. So we need to say what our probability of each one is happening. So the 2 options could be 1 or 5, and the probability of each one happening, well, the 1, 2/3 of the counters are 1, so the probability of pulling out a 1 is 2/3, and the probability of pulling out a 5 is 1/3. So we have our probabilities there. We now need to look at the possible ranges, looking at our different samples. So these are all the possible samples. On this first one, the range is 0, so that's a range of 0. And on the bottom one down here, this one also has a range of 0. The 2 middle ones, so 1 1 5, the range there is 4, and the range here is also 4, so both of those have a range of 4. So we need to find the probabilities of each of those happening. So there are only 2 possible ranges. The range is either 0 or it's 4, and the probability of there being a range of 0 is either 3 1s or 3 5s. So that's going to be, the probability of getting 3 1s is 2 over 3 to the power of 3. We also need to add to that the probability of getting 3 5s, which is 1 over 3 to the power of 3. Just going to draw a little table here to help divide up the work. We'll work that one out in a minute, but let's look at 4 now. So, looking back at our samples of 4, we can either get 2 1s and a 5, and that happens 3 times. So let's represent that. So it happens 3 times, so it's going to be 3 times 2 1s, which is 2/3 to the power of 2, times 1/3, which represents the 5. And also then we've got this row here where there are 2 5s and 1 1. That also happens in 3 possible ways. So it's going to be, add to that 3 times 1/3 to the power of 2, because we've got 2 5s in this one, and multiply that by 2/3, which is the probability of getting a 1. And finally, this, we just need to work out the probability of either of these happening. This one works out to 1/3, and this one works out to 2/3, and those are our final answers. So probability that the range is going to be 0 is 1/3, and the probability that the range is going to be 4 is 2/3. So we can see that from this small sample you could get varying statistics. 1/3 of the time you're going to get a range of 0, and 2/3 of the time you're going to get a range of 4. Let's move on to looking at the mean now. So I've got the question reprinted here for us to look at. So we're finding the sampling distribution of the mean. Give myself a bit of space. So what we need to do is calculate all the possible means. So the mean of this first column, this first row, sorry, is 1. The mean of the next one is 7 over 3. The next column, the mean of those is 11 over 3. And the mean of this sample here is 5. So the way I've calculated that here, add those together, divide by 3, 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 that gives you the mean. And we now have 4 different possible means. So we need to work out the probability of each of those happening. So again, I'm going to make a table similar to this to divide up the work. So you can say that mean is either going to be 1, 7/3, 11/3, or 5. Again, I'm going to divide it up. So the probability of it being a 1, go back. So probability of this happening is 2/3 to the power of 3. Probability of 7, of the mean of 7/3, remember that was where we had a combination of 1, 1 and 5 in 3 different combinations. So it's 3 times 2/3 squared times 1/3. This one here was where we had 2 5s and a 1, again in 3 possible combinations. So we would do 3 times 1/3 squared times by 2/3. And then finally, where the mean is 5, that's where we pulled out 3 5s, and probability of that happening is 1 over 3 cubed. So if we calculate the probabilities of all of these, this first one is 8 over 27, this one's 12 over 27. This one here is 6 over 27. And the final one is 1 over 27. So again, if you were to do a sample, this sample, there are 4 different means that could come out. The probability of it, each one is different. However, there is a probability that you would get 4 different statistics if you were to do this small sample. Let's finally move on to the mode. Now the mode is exactly the same. We need to find the mode of each sample. So let's go back to our list of possible outcomes, and the mode of this first one is 1. The mode of the second one is also 1. The mode of the third one is 5, and the mode of the last one is again 5. So we've got 2 possible modes here, 1 or 5. Now for this one it was either 1, 1, 1, or it was 2 1s and a 5. And for the 5s, the samples with a mode of 5, it was 2 5s and a 1, or 3 5s. So we need to calculate the probability of each of those happening. Well, 3 1s was 2/3 to the power of 3. We need to add that to 3 times. We're doing it 3 times because remember there are 3 possible combinations of 2 1s and a 5. So we have to multiply it by 3 to represent that. So 3 times 2/3 squared times by a third. And then on for the 5s we have 3 times 1/3 squared times by 2/3. That's where we've got 2 5s. And add that to the other possibilities where we have 3 5s, which is 1/3 cubed. Now if we work this one out, put that in our calculator, this one is 20 over 27, and this one is 7 over 27. So again, the probabilities of getting these modes, more likely to get a mode of 1 than 5, but they're both possible modes from this sample, and these are the probabilities of this happening. In the next video we're going to be doing a little bit more of a complex question with a lot more combinations, and we'll be looking at how we find other statistics such as the median.